In this video, we will look at solving rational equations. Remember from our previous video, we talked about rational equations being those which have a polynomial in both the numerator and the denominator. But now we want to know how to solve for a variable within those rational equations. I've listed here the 5 steps. First, you need to factor all parts of the rational equation, cancel any like terms, identify any restrictions, find a common denominator, and then set the numerators equal and solve. Let's begin by working through an example of one of these. First of all, if we have something such as x minus 1 over 7x equals x plus 3 over 6x. Notice we do have a rational equation in that there are polynomials in both the numerator and the denominator. The first thing we're going to do is factor. There are no parts of this particular equation that can be factored. There are also no like terms that can be canceled. Remember, because there's a minus sign in between here, we cannot cancel the x's on the top or bottom. We can identify any restrictions, and to do that, we take the numerators, in this case, 7x and 6x. Those are not allowed to be 0, and solving in both cases for x, we find that our only restriction is x cannot be 0. To find a common denominator, we look at 7x and 6x, and notice that the least common multiple of those two is going to be 42x. To get these denominators to be equivalent, we're going to need to multiply this side by 6 on both top and bottom, and this side by both 7 on top and bottom. Notice this gives us 6x minus 6 over 42x on the left, and 7x plus 21 over 42x on the right. Once we have gotten the denominators to be equal, we can take the numerators and simply set them equal to each other. That's the equivalent of having a pizza or two pizzas of the same size. You divide one into 8 slices and one into 6 slices, but as long as the whole is equal, the numerators are going to be equal. Here I'm going to solve for x. I subtract 6x from both sides, and I have negative 6 equals x plus 21. Subtracting 21 from both sides, I get x equals negative 27. Let's look at a little more complicated example where we do have to factor and cancel. If we had x cubed plus 3x squared over x squared minus 2x minus 15 equals 4x plus 5 over x minus 5. Our first step is to factor all parts. Looking at the top left, we can pull out an x squared, leaving us with x plus 3. And on the bottom, we can use our AC method, which you can go back and review in previous videos, to get x minus 5x plus 3. The right side is already factored, so we leave it as 4x plus 5 over x minus 5. Notice our x plus 3's cancel, simplifying our equation to x squared over x minus 5 equals 4x plus 5 over x minus 5. In this case, our denominators are already equal, but don't forget to consider restrictions. So we're going to take all parts of the denominators and make sure that they cannot equal 0. Here, this tells us that x cannot be 5 and x cannot be negative 3. Now, because the denominators are equal, we can set the numerators equal, and this leaves us with a quadratic. We have 3 methods for solving the quadratic. We can factor, we can take the square root, or we can use the quadratic formula. Fortunately, this one we are able to factor, so moving everything to one side to set it equal to 0. I can use my AC method again, and I'm left with x minus 5, x plus 1. Remembering the zero product property, which tells us that if two things are multiplied together, one or both of them must equal 0. I can solve for x and I get x equals 5, or I get x equals -1. Remember from our restrictions, x cannot be 5, so our only solution is x is -1.